Hello. Today I will be showing you guys a bunch of different tips and tricks that you can do with the calculator, which is really cool because you can use the calculator basically to cheat on the exam and it's allowed. And I just find that really helpful. So I'm going to show you guys some of the different tools that have found and I like to use. I'll be going through separate sections explaining how the calculator works. I will assume that you have some general knowledge on the functions of the calculator, but I will still go over most of the different modes most of the different modes that you can see on the screen here. I will be going in order for these, so if you think any of these might be useful for you, then feel free to check. I will also, when I put the timestamps, I will make a small note on which mode I think is more useful for which subject or which class or anything like that. Here you can see I do have a digital version of the calculator. This is the exact same calculator as the Casio fx-991 CW. You might also have the fx-991 SP CW, which just means the Spanish version. However, it is the exact same calculations, and if there's anything that is in the Spanish calculator, I will also say the name of the item because I have the physical Spanish version with me too. So I will be translating as we go along too. I will probably make an updated version of the video later on because I don't know all the different commands and I'm still learning to use them, and I can only help you guys based on what I know, based on my knowledge, which would basically be halfway through my AS. First we have the calculate option, which is the one we all know and love. It's perfect for doing any kinds of calculations, for example just a simple multiplication, or most of you probably have used it for things such as trigonometry. So these are some basic functions that you've probably seen. The very first thing is that some people actually don't know this, and I find it sometimes surprising that you can store values. For example, you have a whole bunch of values here. You've got X, Y, Z, and then a bunch of letters from A to F. These top three, pi, e, and I, they are mathematical constants, so we can't use them in this case. However, you can store different values. So for example, if I'm doing a really complex calculation, and then I need to do some, so like I'm doing some sort of trigonometry, for example, and I get a value, but this is a really long decimal, and I want to keep this value because it's more precise. I can click on the variable button and then select the variable by going up or down, left or right. So I'm going to store this in variable A, and then I can click on the store option. And then now if I were to show what A equals, it gives me that exact same answer. That's just a really useful thing that some people don't realize they can do. Another useful thing is not only can you store variables, but you can also store functions. So for example, if you are finding different points on a function, for example in FP1, you need to find what's the value of a very special graph at a certain point, we can define or definir f of x and g of x, and then you can recall them anytime. So if we define f of x, and if you're doing some complex calculation, so you don't want to keep typing it into your calculator, and then I can click execute, and this now saves my function f of x. So if I'm doing some calculation, for example, I want to know what when x is 1, what is the answer? It gives me the answer. So it plugs in all of those numbers so you don't have to rewrite the whole thing every time. That's something that I found really useful in the exam, to do the Newton-Raphson method once or twice or even more times. Those are some of the simpler ones. Of course, there's also something, just a reminder that in the system settings, the calculator settings, we can change the angle unit, for example, because you might have to switch between degrees and radians, so do remember to do that. if you're doing sine, cosine, or tan or something like that, you will need to be using these. Another thing is that we have a catalog. Now the catalog is great because it has so many different functions in here. So there's a function analysis, and here we can see the derivative, integration, summation, logarithm. All the names are quite similar in Spanish too. But let's say I want to find the derivative of something. This formula is super useful when you're doing differentiation in exams. For example, they ask you to find the turning point. We all know that the turning point of a graph has a gradient of 0. So let's say you try to work out what your x value is at that point. So if they asked us to differentiate this, and then I'm trying to work out when does this equal 0, and I find my x value, and let's say my x value is 3. Then I can try to put that in, and if I execute it, it tells me that when x is 3, the gradient of the graph is 3, which is incorrect. We want it to be 0. So then you know that your answer is wrong in the exam, which obviously is a bummer, but that also means you have the chance to redo the question and correct your mistake. So then you could try again, and then you think, okay, I think it's 3/2. And then you try it and you find out, oh, the answer is 0, which means that the gradient is 0 at that point. So that means your calculation was correct. And you were able to find the turning point quickly. Another thing is that they also have integration, but that's something we do in P2. I haven't done this yet, so I can't explain it properly to you how it works. But of course, like I said, I'll make an improved video later on. But it's very helpful for P2 because that's when you start actually using integration to find specific numbers. There's also summations. In FP1 you do use summations, but this hasn't really been helpful to me because the way you do summations in FP1 you don't actually need this formula. And for people that do statistics, you might be thinking you've seen that number before and this is useful for you. It is, but there's another one which is more useful for S1, and I'll show you guys what that is. That's in another section. You can scroll ahead if you want to find that. We also have probability functions, which are like factorial. This is very useful for finding a few different things, maybe in statistics later on. Then if we scroll down a bit more, there are some engineering symbols, which are basically, if you forget how to convert, this is great for physics and chemistry and biology, more science-based. If you forget how to convert from micro, so if I have, for example, 1 micrometer, that's the same as, I can change this to decimals, 1 times 10 to the minus 6 meters. So that's a way that you can use this to help you remember your conversions in the exam. Even cooler, if you do any sciences, I'd recommend going through some of these. You can find scientific constants that are quite useful. I believe somewhere here. For example, one of the options, if you just look through the whole bunch, there is C, and this number is the more accurate version for the speed of light. Now in A levels and in GCSE, we use a rounded version of the speed of light, around 300 million, but if we look here, that is the same number, just more accurate. Another thing that we have is, if we scroll down, so we've had the scientific constants, which are really nice, and then there's also unit conversions, which are they can sometimes be useful. I don't see them used too often. In the younger years, they still ask you to do conversions between kilometers per hour and meters per second, but you can also just type it in immediately. So if we take this, all I have to do is write, for example, what is 1 kilometer per hour converted to meters per second, and it gives you an answer of 0.2777. So that is 1 kilometer per hour is 0.278 meters per second. The other section is kind of just a long way to get something you can already find easily. A quick note is that about the variable storing that I mentioned earlier, I did say that you can store values, but do remember and take note that this is useful when doing a question, but you cannot bring these values into the exam, for example, because, for example, in our final exams, they do ask us to erase our calculator's memory, which does reset all of these values to 0. If I were to go to settings, for example, if I click settings and I reset, they ask you to initialize everything. So if I say yes, and then I go to the variables, you'll see my value of A has disappeared. So for when going into the exam, you cannot use this. The next section is statistics, which, as you would assume, this I recommend using if you do statistics. So in this calculator, you can use one variable or two variables. For S1, so far, we're halfway through S1, we've only needed to use one variable. So that can be, for example, those are our X's. So if you have a bunch of information, for example, ages of different kids in the class, and then you have someone who's 14, someone's 15, another person who's 15, back one more to 14, and then you have a person who's 16 years old, you can collect all of that data and write it down on your calculator. So when they give you this information in the question, they might ask you to calculate different things. For example, what is the mean or the standard deviation? And even though you have to show all of your workings, the calculator can still help you to check your answers. If you put everything correct into the calculator, then if I click execute again, after having typed everything, I can do one var results or variable results or statistics calc. So if I do the one variable results, I end up with this list of values, and all of this is a bunch of information related to the statistics. Here we have the x with the line on top, which is the mean. We have the sum of x, the sum of x squared, which we did before, the variance and the standard deviation, and then even some other things. However, if you click down, you get even more information. For example, you can find the minimum value, which is 14, the smallest, the median, the lower quartile and the upper quartile, the number of values, which is n, and then even the maximum value, which is 16. Sometimes we also want to use frequencies for our data because some questions are given using frequencies. So what we can do is, if I go in Tools, there's the frequency button, and I can click on to switch it on. And then if I go back to my table, you can see now it's cleared all the data. Please make note of that. But I can rewrite all the information. For example, 12 students in the class are 14 years old. There's another 5 students that are 15 and maybe 2 that are 16. And then you can again see your results information, and it will give you all of the data once more. It tells me the total number of people. It gives information about the mean, the standard deviation, which I find really helpful personally to check because that calculation can be a little bit difficult to do. So that is a small guide to the statistics. There is also the distribution section. However, we haven't done distribution yet. We are going to be doing it later on after this video is released. So again, I will probably look into if the distribution can be useful during the exams for once we have done it. But for now, I'll continue on. The next one we have is a spreadsheet. Now, spreadsheets are it's a literal Excel spreadsheet. Now, this isn't really useful for anything specifically in the exam, but you can store information. For example, if I want to store how tall some plants are, and then I have a bunch of information and data, and then I want to sum them all up, it's basically a very small version of Excel in your calculator. I personally have not used this much at all, but if you find the manual, which I will link below, you can read into it, because I did look at the manual and it does explain quite nicely how does this calculation work and how do you use the spreadsheet, but I will not be going into that either. The next is the table of data, which is also quite useful, and it's similar to what I was talking about in the calculate option, where we can define functions in the function section, and then I can say, for example, 9x plus 2 is one function. And then gx, it's telling me that gx does not have any value, which is fine. So we won't be getting gx answers. But if we want to find out what the different solutions are going to be, we can calculate this. So I can put in a few different values for x and then see what my answers are going to be based on that. And I find this is also another just a quick way to visualize a bunch of different values of functions. Perhaps that's useful for you, maybe not. You can use this might be useful if you want to. In FP1, this might be a great way to do interval bisection. That's basically the table again. It's quite a simple section. The equation section is really nice because it has three of the most useful items here in this entire calculator. The first one is simultaneous equations, and if we click on it, we can choose how many unknowns or incognitas we have. So for example, usually we have 2, maybe sometimes 3 in our course so far, but all it's asking you to do is rewrite your formula to be in terms of x and then in terms of y equals a number. So for example, if I have 2x and then 1y equals 8, and then maybe 0x, and I can move to the right here, and 3y equals 9. Then once you've put in your two simultaneous equations, what it's going to do is if you press execute, it calculates for you what the value of x and what the value of y is. And it quite literally just quickly solves simultaneous equations. So if we go back, then we also have polynomial or polynomica, which is basically quadratics, cubics, and quartics. The calculator knows how to quickly solve and find solutions for quadratics, cubics, and quartics. The most common one that we might use is probably the quadratic, so let's open that one. If we have a quadratic equation, you want to write down the equation, and what you're going to write here equals 0. So if I start with and then I try to find out what are the values of x or the roots of x for this equation, and if I execute it, it gives me the first one, x1 equals -1. So here you can see it says the equation that you put in, which it writes like this: when it equals 0, x is -1, or if you press down, x the second value of x is -5. Which is, well, if you factorize that equation and you solve it, you realize that is correct. I absolutely love this feature because when I was in GCSE, I was using this all the time to quickly factorize things. If they were like nice numbers and I could factorize, I would use them. So if the solution here is -1 and -5, that means what you put in the brackets would be x plus 5 and x plus 1, because that does give you this equation when you expand it outwards. Again, when you are solving quadratic equations, you have to show you're working. However, you can still check you're working out using this method. There's also, you can go even more down, and here we can see that the minimum point of the equation of the graph, so like if you had the graph drawn, you would find the minimum point of x is -3. If I plot this graph here, we can see that the minimum point, the x value is -3, and it tells us also the y value is -4. If you're differentiating, you can check using this calculator method too, so that's great. It does give you the minimum points. You probably don't need to solve cubics or quartics unless you're in if you do FP1, you probably have to solve a cubic, but it's the exact same thing. You can find the solutions, use it, put in the values, find your solutions, and then see if they match what you've written. Quartics sometimes appear in any exam, for example P1 or FP1, but they appear like x to the power of 4. There's no x to the power of 3, and there's just x to the power of 4 and x squared, and then that's when you do like for example y equals x squared, and then you solve it and do all of that. So you could still use the calculator to find those answers and see if they match what you have done. The next option is inequality, and if I'm being honest, inequalities can sometimes be annoying in the exams. However, this is the exact same method. We click on inequality, it gives us the 3 different options. So quadratics are most common for us, and then for example, it tells us when a quadratic is greater than 0. This is also great for the discriminant when you want to find the values of k, for example, in the P1 exam questions. And if you find the equation for k and then you write it down, you can then check it, so then it gives you the answer. So these are, for example, the values. And it even tells you the equations in like with the sign in the correct direction and everything. So here it's literally telling me what the solution would be, perfectly written out, which is again magnificent because I always mix up which sign has to go in which direction, but here it does it for me. So if you do wish to use this tool, I would 100% recommend practicing with it though, because if you put in the wrong thing or you don't know how to use the inequalities tool in the exam, you might end up confusing yourself because these functions are useful, but you also have to know how to use them properly to take advantage of them. You cannot solely rely on your calculator. You have to understand that if you put something wrong in the calculator and it doesn't match your working out, sometimes you are right and the calculator is wrong. So for any of these tools, I 100% recommend trying to practice using them. Do not just rely on your calculator to check your answers. Do practice papers and then use the calculator to check and see if it's the same as the mark scheme. The next section is complex numbers. This, so far, I've only seen this in FP1. It works the exact same. It is 100% the same as the calculate option in the very first main setting, which is calculate. But it's quite literally the exact same area. However, this one allows you to have negative solutions. For example, the solution here is 2i. If I did that in the regular calculator, I would end up with a error. The catalog in this one also has complex function analysis. For example, you can get the number I, you can get the conjugate, which part is the real part of a calculation, which is the imaginary part. If you remember, the real part's the one with real numbers and imaginary is the one with I in it. And it can even calculate the argument for you. So if I have a very simple one, 1 plus I, and I'm in degrees, so that answer should be 45, because if we think about the complex plane, is 1 plus I, those are the same lengths, it's going to be at 45 degrees. And you can even calculate this. It's tan minus 1 divided by 1, and that gives you 45. So it does work. I believe it also does take into account, in this case, if it's in a different quadrant. So let's do 1 minus I. It's minus 45. So it's calculating it. It's making sure that everything's correct. And if you then notice, I'm pressing Shift 9 to generate I because that's written here. If you try to do that on the normal calculator, it won't work. Another thing I like about this version is that if I do, for example, it calculates the final value for you, because sometimes they ask us to write this in the form a plus bi, which is nice, but which I mean, if they sometimes ask us to write in the form a plus bi, but that then we want to check our answers, we can do this now using the complex section of the calculator. Then there's the base n section of the calculator, which I honestly don't know how it works properly, but you do not need to use it, at least so far. I've looked into it a bit, but I don't see what it does exactly. I think it's more an IT thing, but I don't do IT A level. It might be related to IT, I'm not sure. The next one is matrices, which we have seen, for example, in FP1. There are matrices. I know that some other courses have also been doing it. And the very first thing that appears is that it says press tools to define matrix, which means we can, if we go to tools, it gives us a list of 3 different matrices. And if I choose one, so if I click OK, I can decide the matrix size. So if you do FP1, then it would just be a 2x2 matrix that we're working with. So if I click OK, and then I have a matrix. So I can see, okay, what would that matrix be? -2, 5. So maybe you have a matrix and it looks like this is your matrix in the exam. If you click execute, it has now saved that, because if I go back to tools, it shows mat A is a 2x2 matrix, and then the others, they don't exist yet. But now if I go to my catalog, I can click matrix, there's a matrix option, and I can click on matrix A, and if I click execute, it gives me the answer, which is just matrix A, because I'm not doing anything to it. I could, for example, I could multiply the matrix by 2, and then I double all the values. But probably more useful to you is if I go to the catalog, matrix, there are matrix calculations. For example, squaring the matrix or cubing the matrix, but also the determinant of a matrix, which is -28 in this matrix. So you could calculate that yourself and see if that's correct. But then we can also, for example, find what is the inverse matrix, because this matrix has a determinant that does not equal 0. We know that it will have an inverse matrix. So if I do that, just -1, and it calculates it for me. And it even gives me the exact values if I want them, because they write it always as decimals here, but it's saved as the exact value, so like 1/14 and all of that. But that would be the inverse matrix that we're doing. Then that, if you go to the matrices, if I scroll down, not only do I have matrix D, I also have the matrix answer, so I can use the previous matrix if I want to. So yeah, you can use matrices, and this is great for combining matrices, for example, and multiplying matrices, because it takes so long and it's so arduous to multiply matrices personally. So if I am multiplying them and I'm worried that I might have made a mistake somewhere along the way, I can write down those 2 matrices and then multiply them together and see if that gives me the same answer as I calculated. Matrix B I left empty, so everything's going to end up being 0. But here we can see that that would technically be the correct answer. We also have the identity matrix here, which can be written as, which you tell it which identity matrix do you want, because the identity matrix is always n by n. So we were working with the identity matrix 2, which is the 2x2 identity matrix, which is just 1 0 0 1. So you can even use identity matrices if you want, or there's a, if you're curious, the third identity matrix 3 would just be 1 0 0 0 1 0 0 0 1. And yeah, so that's how the matrices work. The vectors tool, as much as we want to use vectors, here you can see that the tool tells us that we can press tools to define a vector. So if we go to tools, it will say, then it'll give us VCTA, which is vector A, vector B, vector C, or vector D. So we can store 4 different vectors at a time. So if I click it, There we can have vectors in 2 dimensions or in 3 dimensions, but most of our vectors are in 2, so I'm going to leave it like that, and that gives me this vector. If you just saw my matrix explanation, the previous one, it's all the same tools basically. Um, we can give this vector a certain number. I can store another vector, for example. I can store -9 and 8. And we can, and then if we have defined vectors, we can go to the catalog, click, the first option is now vector, so we click OK. And then we can choose from our vectors. So you can see it gives us the 4 vectors which you can save, and your answer, a vector answer, which would be the previous answer that you got when using your vector. So if I do, for example, vector A plus vector B equals -7 and 11. If you remember in A-level mechanics, sometimes they ask us to add vectors together and they use the IJ notation. So this would be the same thing, honestly. You could say that I is the top value and J is the bottom value. So this would be -7I plus 11J in terms of vector in the IJ notation, but it's still quite similar, so it is nice to write. Those are basically the things that you can do with vectors where you just add them together. So this tool is honestly not that interesting. There are some other things you can do, but we don't have much use for them yet. I'm not sure how to use them exactly, and I don't know if we will need to be able, they might be useful to us in the future, but so far they haven't been. So I would leave that at that. And the last section is the math box, which is quite interesting. This digital version does not have as many options as my manual version does. If I click on math box on my manual, I have a dice toss, a coin toss, and I have 2 more options. Let's just go through the ones that I do have here first. So, for example, this is honestly just some fun and games. So I could have a dice roll and I'm gonna roll it 5 times, and we can it rolls it. On your calculator it does a cool animation, but the digital version is not that cool. So I can write a list or relative frequency table just to see what the answers are. So I rolled a 2, 1, 4, and 6. Fair enough. Then I can also do a coin toss, which is I just toss a coin a bunch of times, and then I can see heads or tails, which it does as a filled dot or not filled dot, and it repeats. Wow, very unfair dice. Then there's also the options which I have here on my real calculator, but I can't show them. If you have the physical calculator, I'm using the fx-570 SPCW. Maybe this is just the SP version, but I doubt that because that just means Spanish. There's the recta real, which is a line, and this is probably the most useful out of all of them, out of all the options in the math box for me, because I can choose the different A, B, and C here. I can choose different types of lines to make using different types of inequalities to represent on a number line. So if you click on any of them and then you fill in some values, like I just made a equal 2 is less than x is less than 3, I now have a small line that goes between 2 and 3 on my number line, and you can actually move around this number line if you try, and you can see which points are where. And this, I find this useful when I'm trying to find inequalities that add together. So I would put 2 inequalities and see the part that they overlap. So when they are both true, that they might ask that in the exam, so you can use that. But again, it's too much work to really try. And then the last one is, I've looked into it, it's not that interesting, trust me. But that one's, it's called the circunferencia here, circumference, I guess. But it's not on the digital calculator. But those are the last 2 sections which just don't appear. on this digital version. But that is the entire Casio FX-570 or 9-in-1 CW information, which you can use for during your exams. It's allowed in the examination, and it has a whole bunch of different features which you can use to help check your answers. Once again, you cannot use these to get your answers and then cheat on the exam or something like that, because you need to show all your working out and things like that. But in a sense, you can still cheat because you find the solutions and you can check your working out using the calculator and all of the methods that I just discussed. So I will be releasing maybe later on a updated version because this is limited. However, there is also the older calculator which some people prefer to use still, which is the FX-9-in-1 Classwiz, and some people just prefer to use that calculator instead. I will also be making a video explaining all the features on this calculator, which are actually quite similar to this, to the FX-9-in-1 CW, so that's nice. I hope this video in the end was helpful to you guys, and you now know a little bit more about your calculator and how much more it can actually do than 3 times 5. But oh well, thank you very much.